Okay, I have a question for you. How can you turn an open statement into a statement? So let's say, for instance, let's write P of X to stand for X is positive. That's an open sentence, right? What does an open sentence mean? Open sentence means it depends upon a variable and it is by itself neither true nor false. So it's not a statement. Okay? But you can turn it into a statement by doing something that we've already said before. And that's my question for you. How do you turn an open sentence into a statement? And what I want you to be saying to yourself right now is that you can turn an open sentence into a statement by plugging in a specific value. So, for instance, P of 2. P of X is an open sentence. It's neither true nor false. But P of 2 is a statement. It is true. And P of negative 5 is also a statement. It is false. Okay? Now you already know all of this. What I want to teach you today is there's another way to turn an open sentence into a statement. And that is by adding what's called a quantifier. And there's two kinds of quantifiers. You can, here, let me say it like this. I can take P of X, which is an open sentence, and I can build it into a statement by saying, there's a few ways to say it, and I'm going back and forth on how I want to say this. So here, P of X for all X. In the real numbers, let's say. Or P of X for some X in the real numbers. Those are both statements. The first statement says X is positive for all real X. Or another way of saying that is saying all real numbers are positive. Okay, that is a statement. It is a false statement. Okay? The second one says P of X for some real number X. That's saying that X is positive for some real number X. That is a true statement. So you see, by taking an open sentence and saying the open sentence is true for all of something, or for at least one of something. That's two ways to build a statement out of an open sentence without plugging in a specific value into X. Okay? That's called quantifying the sentence. This first type of doing it here, that's called universally quantifying P of X. And the second way of doing that is called existentially quantifying P of X. Now, in logic, you normally, and I strongly suggest doing this as a rule, putting the quantifiers at the beginning. So I would rewrite that first example like this. For all X in the real numbers, comma, P of X. That's how I want you to be writing them. That's the way we would normally do it in logic. It doesn't mean it can't be written in a different order, but I would very strongly caution you against trying to get creative with the order of things. So many people rearrange the order of words thinking that they're saying the same thing, when the reality is, by changing the order, they have completely changed the meaning of their sentence. Okay? Instead of for all, you can certainly say for every X in the real numbers, X is positive. Or you could say for each X in the real numbers, X is positive. Those all mean exactly the same thing. Okay? That is, of course, a false statement. I'm not claiming that every real number is positive. Remember, a false statement is just as good of a statement as a true statement. If your question is it a statement or not? Okay? All right. So that's called an existentially quantified, a universally quantified statement. Okay? Now let's go down to the existential one. So I would normally, and just about everybody would normally do it this way. You put the open sentence at the end and the quantification at the beginning. So you would say, for some, no, what am I talking about? That's not right. Yeah, it is. That does work. For some X in the real numbers, X is positive. So that's saying there is at least one real number. What does the word sum mean here? How many makes up a sum? Sum means at least one. In fact, you could say, for at least one X in the real numbers. Or you could even just say for an X in the real numbers. That means the same thing. All of those do. Okay? Now the normal way of saying it is this. So all of those are fine, but here's the normal way. We would normally say there exists some X in the real numbers. I need more room here. Such that X is positive. That's the normal way of saying it. You can say there exists an X instead of some X. You could say there exists at least one X. Those are all equivalent. Okay? Since you're just learning this stuff, I want you to get used to the idea of saying for all and there exists some such that. Okay, once you get used to it and you know how it works properly, then you can maybe change up some of the wording. It's okay for me. I said I want you to say for all. You can say for every or for each. That's fine. Those are the same. I don't mind that. And I said to say there exists some such that. You can say there exists an. You can say there exists at least one, although I don't know why you would. That's 3 times as many words as you need to say. Okay? But what I mean is I don't want you right now trying to get fancy and saying things like, how did I say it before? Oh, before I said for some x in the real numbers, comma, p of x. I would rather you not write it that way. Not right now. I want you to get used to saying there exists such that. Okay? Now, the book does something that I think is odd. I've not seen this before, and I'm not on board with this, and that is the author of the book, he leaves out the words such that, and he puts a comma there. To me, that's just grammatically wrong. It's not a question of logically right or wrong as much as it is a question of grammatically right or wrong. And I firmly feel that your mathematics should be just as grammatically correct as it should be mathematically correct. So I'm going to put the words such that, and I always will. You'll never see me leave that out and put a comma. It's very awkward, and I don't even think it's correct grammatically. It would be correct grammatically if I had written this as for some x in the real numbers, comma, p of x. That's grammatically correct. But as I said a minute ago, I would like you guys, at least at the beginning, to use the words there exists. And with that phrase, it is mandatory to have the words such that, otherwise your sentence just isn't a proper English sentence. Okay? Now we have symbols for both of these quantifiers. The symbol for all looks like an upside down capital A. And the symbol for there exists some looks like a backwards capital E. Okay, so we would say, if you wanted to say every real number is positive, here's how I could write it symbolically. Okay, that says for all x in R, x is positive. Or every real number is positive. Okay? And that is a universally quantified statement. That is false. Okay, this one down here, this existentially quantified statement, I would write like this. Now, in the book, it'll look like this, but like I said a minute ago, I don't think that's grammatically correct. I am okay abbreviating the words such that with an ST. I'm fine with that. It's still grammatically correct because when you read it out loud, you still say the words such that. Some people use this symbol for such that. I'm going to ask you not to do that. I really dislike that symbol because it looks too much like I'm saying p of x is an element of the real numbers. I'm not saying that, but I could see how somebody reading that might think that's what I'm seeing. So I'm going to ask you not to use that symbol for such that. If you want to abbreviate such that, then use ST. Okay, so that says there exists an x in R such that x is positive. Or A shorter way of saying that is there exists a positive real number. That is a correct statement. Okay? Now you can put these together. Like something like this. What if I want to say every real number has a cubed root? Or is it proper to say a cube root? Because you wouldn't say a squared root, would you? Okay. So when you look at that, it should jump out at you that that is a quantified statement. What kind is it? Well, it's certainly a universally quantified statement, right? Because of the word every. That's saying for every real number x, x has a cubed root. Okay, but x has a cubed root is an existentially quantified statement. It's saying there exists a number that is the cube root of x. So that very simple, unintimidating statement there, every real number has a cube root, is actually pretty complex. It's saying for every real number, there exists a real number that is a cube root of the first. Okay, how would I write that with symbols? I would write this. For all x in the real numbers, and again, talking about grammar, there should almost always be a comma coming after that phrase. There exists a y in the real numbers such that, now we could say y equals the cube root of x, but let's say it this way. Y cubed equals x. Okay? That's what you would call a universal existential statement, which is not to be confused with an existential universal statement. And this is a big mistake that people often make. They think that if you change the order of those quantifiers, it won't make a difference. But here's something you need to be really careful about. Changing the order of those quantifiers changes the whole sentence, the whole statement completely. It does not even mean the same thing anymore. In words, that second one is saying there is a number that is the cube root of every real number. That is, of course, not at all true. There is not one number that is the cube root of everything. You see, this up here is true. This is false. That alone tells you that they do not say the same thing. So when you have two quantifiers, the order is crucially important. Make sure that if you're writing the sentence, make sure that you're writing it correctly and what you're writing really is what you mean. If you're reading the sentence, make sure that you are understanding it correctly and you're understanding what they are really saying. Okay? Let me point this out. Every universally quantified statement can be written as a conditional statement. Is that one still up here, that example? Yeah, look at this here. Let me erase some of this extra stuff. So this statement right here, which is a universal statement, for all x in R, x is positive. That can also be written as a conditional. If you just really, really don't want to use a quantifier, then you can get around that by saying, if x is in the real numbers, then x is positive. Okay, so that's just good to remember. Every universal statement is also a conditional statement. It's not worded as a conditional statement, but it can be. That doesn't necessarily mean that every conditional statement can be worded as a universal statement. Not necessarily. Okay? All right, let's just do a few practices here. I'm going to have to end soon. This is not going to be a very long lecture today, but I just want to do a few practices. All right, let's look at this one. For every prime number p, there is, I think there should be a comma there if you ask me, there is another prime number q with q being greater than p. How could I write that using quantifiers and symbols? I would write it like this. Let's say that p equals the set of prime numbers. Let me define that symbol that way. Then I could say, for all p in capital P, comma, that takes care of this part. There exists a q in capital P, that takes care of this part. Such that q is greater than p, and that takes care of this part. Okay? And I just want to point out that, I guess technically, now that I think about it, the word with should be actually highlighted in green. And I just want to point out that q is greater than p by itself, just that part I highlighted in blue. What is that? That is an open sentence. It's not a statement. It's an open sentence with two variables. Now I put two quantifiers on top of that open sentence. One quantifier for the variable q and one quantifier for the variable p, and that turns into a statement. Is it true or false? Think about that. I won't say, but just think about it. Let's look at this one. And then I'm going to have to stop. There exists a real number a for which, for which is just another way of saying such that, just like up above in that last example. With was another way of saying such that. Okay, for which a plus x equals x for every real number x. How can we write that in symbols? So I would say there exists an a in the real numbers such that, so that takes care of this. What next? For all, for all x in the real numbers, that takes care of that, comma, a plus x equals x. And that takes care of that. Now, could I have written it this way? Oops. More like the ordering that it was in the original sentence. The answer is yes, that is logically equivalent, but I don't want you to. You guys are just learning this. I mean, theoretically, I am assuming that you are just learning this, and I want you to be in the habit of putting the open sentence at the end, which is the part I've been highlighting in these two examples as blue, and putting your quantifiers at the beginning. So yes, I can write it the way it is at the bottom, but I don't want you guys doing that. Changing the order of the universal quantifier and the open sentence does not mess it up, but changing order in general can mess things up, so I don't want you changing order at all until you get good at it, okay? The big danger is when there's two quantifiers and you change the order of the quantifiers, then you have completely changed the sentence. Okay, we're going to do more of this in the next lecture, but that's going to have to be all for today. Sorry about that, but I have something to attend to, so I'm going to end this lecture right now. And I will be back with you in the next lecture.